And welcome back, students. We're going to actually start using the LC3 now, and we're going to look at our very first program. So here's our first program, and this is the code for it. You can see there's multiple lines here. There's about 10 lines of code for it. And you'll note that the code is written using binary. And you can see it, with it being binary, it's pretty lengthy. We could also use this using hex or assembly to kind of actually clean it up, make it easier to read, but we'll actually look at that in the next few lessons. So in order for us to actually examine what this code is doing, what we're going to do is we're going to use comments to tell us what the code does. And for us to use comments, we of course use a semicolon. So here's our first line of code. We have 0011 000 000. This tells it to start the program at location 3000. Then we have 0101 001 0011 0000. This clears register 1, which is going to be used for our running sum, because what we're doing is we're going to end up adding some numbers here. And if you remember 0101, that is used to clear registers. Again, here's another 0101. All right, and if you notice now, this is clearing register 4, which is going to be used to counter. If you're unsure of how am I getting register 1 and register 4, if you recall, you have this. If you remember, we went over the different structure of how the opcodes work and stuff like that. This first three bits right here, or first four, excuse me, are the opcode. So here's an and, and then here is register 1. You can see it says 001, and this is register 4, 100. And you can see when we remember the 1 there, that's pretty much indicating that we're going to clear it. So get the register you want it to be in, store the register you want those values to be in. So we're taking the values of register 1, comparing it with the values of register 1, and we're changing them out to 0. Pretty much we're taking and clearing everything out of that register. Then we have 0001, 100, 100, 101, 010. We're going to load register 4 with the number 10, or the number of times to add. So you can see right here, again, register 4, register 4. This right here, if you look at this in binary, is the number 10. So that's 8 and 2. 8 plus 2 gives me 10. Then we have a load command here, 1110, and then we have 010, and then 011111100, load the starting address of the data. So this is where we're getting the starting address. Right. Then we're going to load the next number to be added, which is using this string here, so 0110, 011, 010, 00000. And then we're going to increment the pointer. And then we're going to add the next number to the running sum. Lastly, we decrement the counter. And then we do it again if the counter is not yet 0. And finally, we get to a halt command. So pretty much this looks to keep going up until 10. And so it's going to decrement that down. When it hits 0, it stops the program. All right. Now, the binary might be a little confusing to look at, but that's okay, because what we're going to do is the next few lessons we'll look at how does it work with hex, how does it work with assembly, and it's going to start making maybe a little bit more sense than with binary, because with binary is a lot of zeros and ones and can get easily confusing if you're not keeping track of the zeros and ones. So let's look at how to save this binary program first off. So we're going to click on the save icon or choose save under the file menu. We'll create a new folder to save into because you're going to be creating more files in the same place when you turn your programs into object files. So on your network drive, your N drive, you're just going to create a little folder for computers and logic and create one like a subfolder for the LC3. Call your program addnums.bin since we have typed it in binary. Right. Creating the object file is pretty easy to do. Before the simulator can actually run your program, we have to convert that program to a language the LC3 simulator can understand. It actually can't directly understand binary. You have to convert that over to what the LC3 can use. And that's because the simulator doesn't actually understand the ASCII representations of hex or binary that we typed into the LC3 editor. It only understands true binary, so in order to do that, we have to convert your program to actual binary and save it into a file called addnums.object. if you're using LC3 edit, one and only one of these buttons will make that happen. If you notice, there's a B, an X, an ASM. B stands for binary, X is for hexadecimal, and ASM is for assembly. So we're going to press the B button since our code is in binary. Then we're going to save that file to the same location we saved our binary addnums file. And let's actually take a look at how to do this. Rather than me just telling you, I'm going to show you. So let me just go to the desktop quick. And you can see here I have two applications here for the LC3. I have the editor and the simulator. We're going to look first at the editor. So let me go ahead and open that up. And you can see the editor is just a plain text editor. There's nothing really too fancy about it. And what I'm going to do is I'm going to go ahead and type in the program that we had earlier. All right, so I went go ahead and I typed that all in there. And you can see here's our program. And I have all those nice little spaces and stuff in there. And of course, you can, if you're typing this in here, you don't have to put these spaces in here. You could just put that in like how we had it back in our slide here. If you just put it in like this with the comments after that, that is perfectly acceptable. So what I'm going to do now is I'm going to go ahead and create the object file. But first I want to save this binary file, so I just click the save icon. All right, and I'm just going to put this on the desktop for now, simply because it's going to be easier for me to access. So I'm just going to call this add nums. And you can see it's going to say source code ASM binary or hex. So because this is a binary file, put .bin after it and click save. And you can see now on the desktop there's an addnums.bin file. Then I want to convert this over to an object file. So I'm going to click on the B here. So it says convert from base 2. You can see this base 16 and this is assemble. So we of course have a binary, so we're going to click on that. And it says converting from base 2, convert complete, 0 errors. And you can see there's this object file now on my desktop that says add nums. Right. Now, even though we haven't done it yet, I'm just going to briefly show what the simulator does. I'm not going to really walk through that. But in the simulator here, this is what we're going to eventually look at using here. It's the LC3 simulator upcoming. Right. So we're going to eventually load our programs in here, and you can see this actually will start giving you some concrete things of what we talk about. When we start talking about registers, we start talking about memory, we start talking about all those different things. So with the LC3, there are three pieces. There's the editor, where we create our programs, and there's the simulator, where we run our programs. Now, in the simulator, you can see up here are those 8 registers that we've discussed, R0 all the way to R7. Right, this PC is your program counter. You have a couple other things in here that you might remember. Of course, you have in here all these different addresses, starting at address 3000. And you can see when the program first starts, because there's nothing loaded into it, everything is set to 0. Once we start loading a program in here, you're going to actually start seeing values appear here. Additionally, if we have some kind of input-output thing going on, you might see something appear here in the console. Right? So this is kind of like if you've ever looked at command prompt, it's kind of similar to that. It's just a console for you to go in and interact with the interface of the LC3. All right, that concludes our lesson for today, folks. Next time we're going to do the exact same program, but we're going to do it using hex, and you're going to see how much easier that could potentially be in hex. All right, until next time.